All right, in today's class, we talked about same parallelograms and different bases. From previous classes, we talked about how we can use any side of a parallelogram as the base and still end up finding the same area. So this problem tells us that there are two copies of parallelograms. A copy is basically an identical parallelogram, and so basically when we copy something, we should have the same thing. Therefore, both of these parallelograms should have the same area. So question 1 tells us that the base of the parallelogram on the left is 2.4 centimeters. Its corresponding height is 1 centimeter. So it asks us to find its area in square centimeters. So from previously, we talked about that to find the area of a parallelogram, we use the formula base times height, which equals area. In this problem, it tells me what the base is, so I'm going to plug in 2.4 for B, or 2 4/10, and then its height is 1. So I'm going to plug that in, and then that's going to calculate my area. So my area for this problem is 2 4/10 centimeters squared. All right, so that's problem 1. On problem 2, it says the height of the parallelogram on the right, so this parallelogram, is 2 centimeters. How long is the base of that parallelogram? So we're going to use the same formula, base times height equals area. In this problem, they tell me what the height is. The height is 2. Going back to this problem up here, it told us that we have copies. So the area for this parallelogram right here should also be 2 4/10. And our base is unknown. Now right here I have basic algebra, and so in order to isolate this b or get this b by itself, what we're going to do is we're going to do the inverse operation. In order to do that, currently 2 is being multiplied to b, so to undo that we need to divide by 2. When I divide by 2 on this side, what happens is 2 divided by 2 becomes 1, so I'm left with b. And what I do to one side I also do to the other, so I do 2 4/10 divided by 2. So over here, this looks like an improper fraction, so I'm going to do 2 4/10 divided by 2. Remember, when dividing decimals, the decimal shoots straight up, and then I divide like normal. So 2 goes into 2 one time, I subtract 2, I'm left with 4. 2 goes into 4 2 times. So the base of this is 1 2/10, 1 2/10 centimeters. So for this type of problem, understanding that if we have two parallelograms that are exactly the same, they're copies, they should have the same area, but the base can be different, because remember, you can use any side of the parallelogram to find the area, just depending on which number they give you. This is an important question to make sure that you understand how to do, because I will probably ask you how to do this in the future on a test or quiz. So the second part of today, we looked at these quadrilaterals, and so to find out if two polygons are identical, they need to match up exactly when placed one on top of the other. So we had to draw one line to decompose or break apart each of the following polygons into identical triangles if possible. So we have to have two identical triangles when we cut this. So in A, we found out that if we cut this polygon like this, we're going to end up with two identical triangles. So A works. In B, we cut the polygon like this, which also indicates that that has two identical triangles. In C, I can't cut from any corner to make two identical triangles, so C does not work. D, I can cut from either edge, right? So from either corner, from corner to corner I can cut, and that's going to give me two identical triangles, so D also works. E is working from any corner, I can't make two, so E does not work. From F, from a corner to a corner, I can make two identical triangles there, and from G, I can also make two identical triangles like that. So looking at this, right, it says which quadrilaterals can be decomposed into two identical triangles. We found that quadrilaterals A, B, D, F, and G can be decomposed into two identical triangles. Okay. Tells us that we need to study the quadrilaterals that can in fact be decomposed into two identical triangles. What do you notice about them? Write a couple observations. So from class, we talked about the observations that we made was that all of the quadrilaterals are parallelograms. So all of the quadrilaterals are parallelograms, which means they have two pairs of parallel sides. So this observation allows us to understand that any time that we have two identical triangles, if we put them together, they are going to make some sort of parallelogram, whether that be a square, a rectangle, a rhombus, or a parallelogram. So with that understanding, you should understand that area for a triangle is base times height divided by 2. We talked about what this 2 represents. This 2 represents that it takes two identical triangles, to make a parallelogram. Thus, when I do base times height, I have to divide it by 2 to find out what one of those identical triangles' areas would be. And that's an important concept to understand, especially for any upcoming tests or quizzes. On this page here, we worked with some triangles, and we had different triangles for this. And so we had triangles P, Q, R, S, T, and U. Of these triangles, 4 of them could be composed into a rectangle. Remember, composed means that we rearrange the shapes into the shape that we were looking for. So P, S, T, and U can be composed into a rectangle, and for a parallelogram, all pairs make a parallelogram because they're all identical. Thus, they would all make a parallelogram. And so this right here, these are my favorite sort of questions where it's sometimes all or never. And so using this information up here, we found that some of these pairs of identical triangles can be composed into a rectangle, and then that all of these pairs of identical triangles can be composed into a parallelogram. Down here, our rule was that in order to find out if a quadrilateral fits, if a quadrilateral is able to be decomposed into two identical triangles, it must be a parallelogram. It must have two pairs of parallel sides. That are congruent. So to sum this up, the most important concepts from today's lesson is that two identical triangles put together will always make a parallelogram, and that in order for a quadrilateral to be decomposed into two identical triangles, it has to be composed of a parallelogram. Those are the two most important things from this lesson. So that's all for today.